Welcome, students. Let's continue our chapter Matter in Our Surroundings. So far, we have discussed about the evaporation. We have studied that whenever a liquid evaporates, it must be supplied the latent heat of vaporization, right? Now, students, the cooling caused by evaporation is based on the fact that when a liquid evaporates, it takes the latent heat of vaporization from anything which it touches. And by losing heat, that anything gets cooled. So, keeping these points in mind, we'll have various examples of the cooling that's caused by evaporation. So, basically, whenever a liquid evaporates, the particles of liquid they absorb heat from the surrounding or anything which they touch and evaporates, and the surrounding and that anything becomes cold. That is the effect which is caused due to evaporation, and that effect is cooling effect. So evaporation causes cooling. Say if we put a little spirit or acetone or petrol or nail polish remover at the back of our hand and wave it around, we'll see that the spread that the nail polish remover that evaporates rapidly, and in fact our hands feel very cold. Why? This is due to the fact that to change from the liquid to the vapor state, this remover, this requires latent heat of vaporization, and it takes this latent heat of vaporization from our hand. And when our hand loses heat, we feel cold. Our hand gets cooled. So this is an example of cooling that is caused by evaporation. In fact, during hot summer days, water is usually kept in an earthen pot, right, in matka, to keep it cool. Now, how it gets cooled? Basically, the pot has a large number of um, small pores or holes in its walls. Some of the water continuously keeps seeping through these pores to the outside of the pot. Now, this water evaporates, changes into vapor continuously, and takes the latent heat that is required for vaporization from the pot and the remaining water. And in this way, the remaining water loses heat and gets cooled. So, this is also an example of the cooling that is caused by evaporation. And yeah, remember here that all the water on the earth, it doesn't get evaporated. Why? Because of the high value of the latent heat of vaporization of water. Okay, in fact, at many places, especially in villages, people often sprinkle water on the ground in front of their homes during hot summer evenings. Why? Again, because the water which they sprinkle that evaporates by taking the large latent heat of vaporization from the ground, from the surrounding air, and by losing heat, place becomes cool, it becomes comfortable. So, in fact, water vaporizing from the leaves of the trees that also cools the surrounding air. That is why we feel comfortable when we sit near trees, because they water on the leaves from the leaves it's continuously evaporating and cools the surrounding air. Okay, in fact, sweating, perspiration, it is perspiration is our body's method of maintaining constant temperature, right? So on a hot day or after doing some physical exercise, what happens, our body temperature tends to rise too much. Our sweat glands they give out moisture, they give out sweat from our skin, on our skin, right? So when this sweat evaporates, it takes the latent heat from our body and keeps our body cool. In fact, in usually in summers, what we wear cotton cloths, right, to keep us cool and comfortable. Again, the same thing. See, we get a lot of sweat on our body in hot summer days. Now, cotton, it is a good absorber of water, so it absorbs the sweat from our body and exposes it to the air for evaporation. And the evaporation of the sweat cools our body. So we can't wear synthetic cloths like cloths made of polyester because they do not absorb much of sweat, and they fail to keep our body cool in summers. Fan, we sit we sit in the in summers we usually sit in front of the fan. Why? Or blow fan. Why? Because it increases the rate of evaporation of sweat from our skin and makes us feel cool and comfortable. Now, cooling in desert room cooler, that is caused by the evaporation of water. Okay, so in fact we are having one common observation also, that is we are able to sip hot tea faster from a plate than from a cup, right? Why? Because the plate has a large surface area, and due to large surface area, evaporation of hot tea or milk is faster on the plate from the plate, right? And this faster evaporation cools the hot tea milk more quickly, making it convenient for us to drink it instead of taking the hot tea from a cup, because it will take time to get cooled. So there are a lot of examples which show us that evaporation causes cooling. Now, in fact, we can also show the presence of water vapors in air. We know that air surrounding us contains a lot of water vapors. So there is always some water vapor in the air around us, which we cannot see. Now, the amount of water vapor in air keeps on changing. Water vapor comes into the air from evaporation of water present in ponds, lakes, rivers, oceans. And water vapor is also given out to plants by the process of transpiration. You are aware about it. Animals give out water vapor when they breathe out air. Land also gives water vapor on being warmed by the sun. All this water vapor goes into the air around us. Now we will have an experiment here to demonstrate that water vapor is present in air. Now it can be shown by this experiment. Like we can take a steel tumbler and or glass, we and put some well crushed ice into it. Then wipe the tumbler from outside with a piece of clean dry cloth so as to make its outer surface completely dry. Okay. Then allow the ice containing in this glass tumbler to stand undisturbed for about 5 minutes. And then you will see that a large number of tiny drops of water appear on the outer surface of steel tumbler or glass. Why? From where does this water come? So basically, the air around the tumbler, around the glass that contains water vapor in it. And when these water vapor come in contact with the cold or the with the cold outside surface of glass, they condense. They form tiny drops of liquid water, and the formation of drops of water on the outside surface of this glass containing ice, it shows the presence of water vapor in air. I hope it's clear to you.